Welcome. Science has illuminated much of the darkness, answering questions our ancestors could only dream of. Yet the more we learn, the more we realize how much we don't know. Some of the greatest mysteries are not in distant galaxies but within and around us, phenomena confirmed by data yet fundamentally unexplained. Today, let's journey to the edge of what we know and glimpse the mysteries that still await discovery. Consider the placebo effect. It's a phenomenon that challenges our understanding of medicine and the human body. A sugar pill, devoid of any active pharmaceutical ingredient, relieves pain. It's not through any direct chemical interaction within the body, but rather, it's triggered by the power of belief. The patient it will work, and that belief manifests into a tangible physiological response. This isn't just psychological, it's not simply a matter of feeling better in your head. Brain scans, using advanced imaging technology, show real measurable changes in brain activity. These aren't subjective feelings, they are objective, quantifiable shifts in neurological function. The body, in response to this belief, releases endorphins, the body's natural pain relievers. These endorphins then bind to receptors throughout the nervous system, reducing the sensation of pain. As a result, symptoms improve. Patients report feeling less pain, experiencing reduced inflammation, and even showing improvements in conditions that seem purely physical. And yet, the only active ingredient is expectation. The patient's anticipation of relief is the catalyst for a cascade of physiological events. The mind's power over the body is undeniable. It's a force that can influence our health, our well-being, and even our perception of reality. But the precise mechanism by which this happens remains elusive. Scientists are still working to unravel the complex interplay between the mind, the brain, and the body. Even stranger, placebos can work even when patients know they're fake. This open-label placebo effect suggests that the act of taking a pill, combined with the ritual of medical treatment, can trigger a healing response, regardless of conscious belief. Its dark twin, the nocebo effect, demonstrates the opposite. It shows that belief can also cause harm. Negative expectations can worsen symptoms, trigger side effects, and even lead to poorer health outcomes. The placebo effect forces us to confront the mysterious bridge between mind and body, a connection that has profound implications for our understanding of health and healing. We can measure the effects, observe the changes in brain activity, and quantify the release of endorphins. But the how, the precise mechanisms that translate belief into biological change, remains hidden. A tantalizing puzzle for researchers to solve. It's a profound mystery at the heart of medicine and consciousness, a reminder that the human experience is far more complex and interconnected than we often realize. In the perplexing realm of quantum mechanics, we encounter a phenomenon that challenges our classical understanding of the universe. It's called quantum entanglement, and it describes a peculiar connection between particles. Entangled particles remain linked, their fates intertwined regardless of the physical distance separating them. This connection persists, seemingly instantaneously, no matter the distance. Whether they are millimeters apart or separated by light years, their destinies are interwoven. Imagine measuring a property of one particle. The moment you do, the corresponding property of its entangled partner is instantly defined. Measure one, and the other instantly responds. It's as if they are communicating faster than light. This instantaneous correlation holds true even across the vast expanse of the universe. It defies our intuitive understanding of cause and effect, suggesting a deeper connection than we can readily grasp. This seemingly impossible connection is what Einstein famously called spooky action at a distance. He struggled with the implications of entanglement, finding it at odds with his theory of relativity. This spooky action defies Einstein's belief that nothing travels faster than light, a cornerstone of modern physics. He believed there must be some hidden variable explaining this correlation. However, experiments based on Bell's theorem have ruled out hidden variables. The correlations are stronger than any local hidden variable theory can explain. The implications are profound. The universe truly is this strange, operating under principles that challenge our everyday intuition. It forces us to reconsider our understanding of reality itself. Despite its mysterious nature, we are already finding ways to harness entanglement. We use entanglement in quantum computing, where it enables computations far beyond the reach of classical computers. Entanglement also plays a crucial role in cryptography, offering the potential for unbreakable codes and secure communication systems. Yet, despite these applications, the fundamental mechanism behind entanglement remains unknown. We can observe and utilize it, but a complete theoretical explanation eludes us. What truly connects these particles across such vast distances? What is the nature of this invisible link that transcends space and time? Is space itself an illusion at this fundamental scale? Does entanglement hint at a deeper, more interconnected reality than we perceive? We can harness the effect, building powerful technologies based on its principles, but we cannot fully explain it, highlighting the limits of our current understanding. Quantum entanglement remains one of physics' deepest mysteries, a tantalizing glimpse into the bizarre and beautiful nature of reality. It beckons us to explore the unknown and to question the very fabric of the cosmos. When we observe galaxies, we find something quite peculiar. They spin at an astonishing rate, a speed that defies our conventional understanding of physics. The visible matter within these galaxies, the stars, gas and dust, simply doesn't possess enough mass to generate the gravitational force required to hold them together at such velocities. According to our calculations, based on the amount of visible matter, these galaxies should be flying apart. So, what's the missing ingredient? What provides the extra gravitational glue? The answer, as far as we can tell, lies in something invisible, dark matter, a mysterious substance that doesn't interact with light. This enigmatic substance exerts a gravitational pull, influencing the motion of galaxies and providing the extra gravity needed to keep them from disintegrating. It's estimated that dark matter makes up about 27% of the universe, a significant portion of the cosmos. In stark contrast, normal matter, the stuff we can see and interact with, constitutes a mere 5% of the universe's total composition. Despite its abundance, we can't see it, we can't touch it, or detect it directly using our current scientific instruments. It remains elusive, hidden from our direct observation. However, its gravitational pull is undeniable. We observe its effects on the bending of light around galaxies, a phenomenon known as gravitational lensing. For decades, scientists have been engaged in a relentless search, employing sophisticated experiments and detectors, all in the hopes of capturing a dark matter particle. Yet these efforts have yielded nothing conclusive. Despite the lack of direct detection, we know it's there, influencing the cosmos on a grand scale. But we have no idea what it is, what fundamental particles comprise this mysterious substance. The universe, as we understand it, is mostly made of something we cannot explain, a puzzle that continues to challenge our understanding of the cosmos. Dark matter remains a profound cosmic enigma, a testament to the vastness of our ignorance and the boundless wonders of the universe. In 1998, astronomers discovered the universe's expansion is accelerating, not slowing. A mysterious force, dark energy, pushes everything apart, overwhelming gravity. Dark energy makes up 68% of the cosmos, yet we don't know what it is. Is it a property of space, a new field, or a flaw in our understanding of gravity? We measure its effects precisely, but its nature is a blank. The fate of the universe is determined by something we can't see or explain. Dark energy is the ultimate cosmic mystery. Consciousness, the inner world of experience, is the most personal mystery. We can map brain activity, trace neural pathways, and correlate patterns with thoughts. But why does any of this feel like something? How does matter become mind? The hard problem is explaining subjective experience qualia from physical processes. No current science bridges this gap. We know what the brain does, but not how it creates the feeling of being you. Consciousness is the mystery through which we perceive all others. Ball lightning, glowing orbs during storms, has been reported for centuries. These floating spheres can pass through windows, hover, and vanish with a bang. Once dismissed as illusion, credible witnesses forced science to take it seriously. Theories range from glowing nanoparticles to plasma bubbles, but none explain all its properties. Its ability to persist and pass through matter defies physics as we know it. Ball lightning remains a rare, real, and unexplained phenomenon. It's a puzzle of light and energy that science can't yet solve. Many animals navigate using Earth's magnetic field, a sense called magnetoreception. Birds, turtles, and others use it to migrate with astonishing precision. We know they sense the field, but not how. Hypotheses include magnetite crystals in cells or quantum effects in the eye. Some evidence supports both, but the exact biological machinery is unknown. This hidden sense is a marvel of evolution and a scientific mystery. How life detects the invisible remains unsolved. The Pioneer spacecraft slowed unexpectedly as they left the solar system, a tiny persistent deceleration. This Pioneer anomaly puzzled scientists for years. Was it new physics, or a mundane cause? The leading explanation, uneven heat radiation from the spacecraft, acted as a minuscule break. Most now accept this, but debate lingers, and similar anomalies appear elsewhere. Sometimes the hardest part is proving the ordinary. The Pioneer anomaly is a lesson in scientific humility. Memory shapes who we are, but how does the brain store and retrieve it? We know memories involve changes at synapses, connections between neurons. Yet, how a specific experience is encoded, consolidated, and recalled remains unclear. Memories seem distributed across networks, not stored in one place. Retrieval is especially mysterious. How do we find one memory among trillions? We understand the building blocks, but not the blueprint. The architecture of memory is a puzzle still unsolved. Sometimes hot water freezes faster than cold, a phenomenon called the Mpemba effect. It's real but unpredictable, and no single theory explains it. Ideas include evaporation, dissolved gases, convection, and molecular structure. None fully account for all observations. The freezing of water, seemingly simple, is profoundly complex. Even in our kitchens, nature hides paradoxes. The Mpemba effect is a humble scientific mystery. Déjà vu, the eerie feeling you've lived a moment before, affects most people. It's not a memory, but the sensation of one. Leading theories suggest a brain misfire. The familiarity circuit triggers without true recollection. Or, a tiny processing delay makes new information feel like a memory. Brain scans show unusual activity during déjà vu, but the cause is unclear. This common experience remains a puzzle of perception and memory. Déjà vu is a glitch science can't yet explain. Blast water with sound, and collapsing bubbles emit flashes of light, sonoluminescence. The temperatures inside may reach millions of degrees, hotter than the sun's surface. We can create and measure it, but the exact physics remain mysterious. How does sound energy focus so intensely in a tiny bubble? Theories range from shock waves to quantum effects, but no consensus. Sonoluminescence shows extreme physics in unexpected places. It's light born from sound, and a mystery in a flask. Proteins fold into precise shapes to function, but predicting that shape from their amino acid sequence is the protein folding problem. The number of possible folds is astronomical, yet cells fold proteins almost instantly. We know the forces involved, but can't predict all structures from sequence alone. AI like AlphaFold has made progress, but the underlying rules remain obscure. Misfolded proteins cause diseases, making this more than academic. The secret code of life's origami is still being deciphered. Protein folding is a molecular mystery. IQ scores rose dramatically worldwide in the 20th century, a phenomenon called the Flynn effect. The increase was too rapid for genetics. The cause must be environmental. Theories include better nutrition, education, and a shift toward abstract thinking. No single explanation fits all the data. Recently, scores have plateaued or declined in some countries. The Flynn effect reflects deep, unexplained changes in human intellect. Why our minds changed remains a societal mystery. Most cosmic rays come from supernovae, but some arrive with impossible energy. The oh my god particle carried the energy of a baseball in a single proton. Theory says such particles shouldn't reach us from far away, yet we see them. Their origins are blank spots in the sky, no known source nearby. Are they from exotic physics or unknown cosmic monsters? These ultra-high energy cosmic rays defy explanation. They are messengers from the void carrying secrets we can't yet read. Acupuncture, an ancient practice, relieves pain beyond placebo in some studies. Traditional explanations invoke qi and meridians, but science finds no evidence for these. Needles may stimulate nerves, releasing natural painkillers, but this doesn't explain everything. Other theories involve blood flow, inflammation, or connective tissue. The mechanism remains elusive, bridging traditional healing and modern science. Acupuncture's effectiveness is real, but its workings are mysterious. It's a medical puzzle still unsolved. Gravity only attracts unlike other forces, which can repel and attract. There's no negative mass, no anti-gravity. Everything just falls together. This asymmetry is unexplained by current theories. Quantum field theory suggests gravity is carried by the graviton but doesn't explain why it's only attractive. If gravity could repel, stars and galaxies wouldn't form. The universe's structure depends on this one-way pull. Even the most basic force hides a deep mystery. Gravity's asymmetry is a question at the heart of reality. We've explored mysteries from the mind to the cosmos, each answer leading to deeper questions. These puzzles are not failures, but signs of progress and opportunity. Today's mysteries are tomorrow's breakthroughs. The next great discovery may come from anyone inspired to ask why. The universe is grander and stranger than we imagine. Stay curious, keep questioning, and never lose your sense of wonder. The journey of discovery continues.